Welcome, everyone. Today we are diving deep into the world of UML sequence diagrams. We will move from understanding basic notation to modeling complex, real-world system interactions, ensuring your technical communication is both precise and powerful. Before building complex interactions, we must first establish the foundational visual language. Our journey begins with the core notational elements that form the basis of every sequence diagram, from simple lifelines to the critical messages that drive the flow of time. Understanding who is participating and when they are active is the bedrock of sequence diagrams. Let's look at how we represent the actors and their periods of activity over time. Each lifeline, signified by a rectangle and vertical dashed line, represents a participant. In UML 2.0, these are connectable elements like objects or ports, not just specific object instances. Thin oblong rectangles centered on a lifeline depict an execution occurrence, or activation. This precisely indicates when a participant is actively executing a method or behavior. Messages are the verbs of a sequence diagram. How a message is sent fundamentally changes the interaction dynamics, from synchronous blocking calls to independent asynchronous events. Represented by a filled arrowhead, a synchronous message forces the sender to wait. This is like a traditional function call where the caller halts until the receiver finishes. An open arrowhead signifies an asynchronous message, allowing the caller to continue immediately. A dashed open arrowhead, in turn, represents a reply returning control or data. A dashed line to a lifeline header shows a create message for a new object. Meanwhile, lost and found messages, pointing to or from a filled circle, handle external participants. Concepts become concrete when we see them in code. This example demonstrates how PlantUML translates textual definitions into a visual sequence diagram, solidifying our understanding of lifelines, messages, and activations. A sequence diagram's power lies not just in its symbols, but in the rigorous rules governing event ordering. These semantic rules ensure our diagrams are unambiguous blueprints for system behavior. The fundamental semantic rule of causality dictates that a send event must always occur before its corresponding receive event, ensuring a logical and unbreakable cause and effect chain. Along a single lifeline, the vertical order of events represents a fixed chronological sequence of execution for that specific participant, which is highly significant for modeling behavior. The vertical position of events on different lifelines is insignificant unless they are linked by a message or a general ordering constraint, forcing an inter-lifeline sequence. Moving to intermediate concepts, combined fragments introduce control structures. They allow us to represent complex logic like conditional branches, loops, and parallel processes directly in our diagrams. An alternative fragment defines conditional if-else branches where only one operand executes. An optional fragment encapsulates optional behavior that executes only if a specific guard condition is true. The loop fragment models repetitive sequences. Paralleled denotes parallel flows running concurrently, while break acts as an exception handler, terminating the enclosing interaction. Here, we see a more complex PlantUML example. It perfectly illustrates how combined fragments like alternative, loop, and optional can be nested to model a realistic authentication workflow with conditional logic and iteration. Beyond combined fragments, other advanced constructs help manage complexity. Interaction references and Lifeline decomposition allow you to break down large diagrams into manageable, reusable parts. An interaction reference, ref, allows you to reuse an entire sequence diagram. Similarly, Lifeline decomposition enables you to drill down into a Lifeline's internal behavior. Gates manage the flow of messages into and out of decomposed elements. Other fragments like neg explicitly define sequences that are invalid and should never happen. Let's tie everything together with a comprehensive real-world scenario. This sequence diagram for an e-commerce checkout orchestrates multiple services, demonstrating how all these concepts work in harmony. Mastering sequence diagrams is about more than just drawing boxes and arrows. It's about crafting clear, unambiguous models of system behavior that drive development and foster team understanding. These diagrams excel at modeling the precise flow of control and data over time. They are invaluable for detailing use cases and requirements in a way that is highly visual and instantly understandable by everyone on your team. Leverage robust tools like Visual Paradigm to unlock advanced features such as code generation and reverse engineering. These capabilities ensure your diagrams remain semantically correct while looking professionally polished for any stakeholder presentation. Thank you for joining me on this journey through UML sequence diagrams. I hope you feel empowered to use these powerful tools to clarify your system designs and enhance your technical communication.